Hey guys, welcome to another advanced tutorial for ACM Game Studio, and today I'm going to be going over a new package that I believe is pretty cool. It's called the Behavior Designer, and what the Behavior Designer essentially allows you to do is to design complex decision trees completely visually without having to code almost anything. So with that, let's hop right in. The first thing you guys are going to need to do is I'm going to need you to download and add two packages. They're going to be the actual Behavior Designer package and the Behavior Designer tutorials package, where there's going to be a few sample scenes. We're going to go over some of the basics. To do that, there'll be links in the README, and then once you've downloaded those package files, you can just go to Assets, Import Package, Custom Package, and as you can see here, I have them both in my downloads. You're just going to click both of them, so you're going to have to do it twice. And what you should get is you should get two folders here, Behavior Designer Tutorials and then Behavior Designer. Within the Behavior Designer Tutorials, you're going to go ahead and click this first scene. It's called just Behavior Tree, and this is going to be just how I introduce you to things. So when you open up this scene, as you can see, it's pretty simple. We have a pretty large plane here. There's a directional light, which is just for aesthetics, um, and an agent and an enemy. The agent has the main camera and a cube below it. Those don't really matter. For now, we're just going to focus on this agent and this enemy. If you can notice, you'll see this little icon next to the agent enemy, and that means they actually have behavior trees associated with them. Um, and you'll see, and you can actually see that in the inspector also with the behavior tree object. A lot of these options are pretty complicated, so we won't be going over that right now. For now, I just want you to show you what the behavior tree looks like and what the behavior tree designer actually adds to Unity. So for that, we're going to go to Tools, Behavior Designer, and Editor. This is going to open up, it'll say Welcome to Behavior Designer, and you'll actually see a tree if you have the agent select, and we're just going to drag this window up into this little area. You can drag the window anywhere, it doesn't really matter, but this is where I like to put it personally. So, as you can see, we can zoom out, we can, move around with these, and we have a completely just normal tree. And you might be able to guess what a few of these things do, but I'll go ahead and explain them on the surface here, and we'll go into more depth later. Entry is essentially where the behavior starts. Selector will select one of two things to do. Sequence will do things left to right, and can see object and seek are things that have been coded separately. Again, I'll explain these later in the tutorial. I just wanted to give you a little bit of a heads up. If you go ahead and click enemy, a different behavior tree will appear. Once again, you'll see behavior tree is an object is like a part of this object or this enemy object, and it has behavior name. You can add a description if you'd like. And like I said, there's a few options, but nothing crazy. They mostly make sense. But as you can see, this one's slightly different, and that's about it. As you can see, you can kind of move around, and you can select a task from the tree to view each of its properties. So like here with weight, you can see what its name is, whether it's instant or not, what the actual wait time is. You can add a random wait, um, and the min and the max if it's going to be random. Seek is something that's been defined by itself. I will show you that script later, but as you can see, it's called seek. You have a speed, an angular speed, an arrive distance, and you can either have a target or a target position. So it'll either go to someone or something. And sequence here is a built-in type that we'll also go over. And just to kind of show you what it's like when we hit play and what I will be explaining is when I hit play, you can see for the enemy at least, it'll light up what's happening. And then you get a check mark if it returns with a success, and a negative if it returns or an X if it returns uh, with a failure. So you can do the same thing for the agent also. You can go ahead and if we restart the scene, you'll see entry, you'll see the selector, and it's currently idle, and then it'll go through and do and seek the red cube. Now you can mess around a bit with that, but now we're going to go in and I would like to explain the some of the basic building blocks of a tree that you'll be using a lot that aren't custom and that are built right in. So for that, we're going to start off with going in with the sequence. Okay, guys, next we're going to be going over the sequence task within the behavior designer. So go ahead and double click on the sequence scene you'll see, which is under behavior designer tutorials. And as you'll see, this scene actually doesn't have anything in it, and that's because we're not really worried about what exactly is in the scene, but more about the specific behavior tree. In the hierarchy, you'll see an object called behavior tree, which once again has the icon. And if you go into the inspector, you'll realize it's just a transform and a new behavior tree. If we go over to our behavior designer window, as we did before, you're going to go ahead and see an entry, a sequence, and 3 weights. Behavior designer is really nice because if you click on a task, you'll actually get a quick description down here. And these are honestly pretty accurate and what I personally were going to say, but I'll repeat it anyways. The sequence task is essentially an AND operation. It'll do all of the tasks below it from left to right, and as long as they return success, it'll keep going. But if it returns failure, it'll immediately stop, and the sequence task itself will return failure. So, to kind of show that in action, we can go ahead and click play. Nothing will happen in the scene, but you can see in the behavior designer how it waits for a little bit, that returns with success, and then it waits, and then it waits. Now, I can also demonstrate to you what will happen if something will return failure. To do this, we're going to go ahead and search for a type of task called return failure. This is a type of task called a decorator, and decorators essentially decorate objects is the best way to put it. It essentially isn't a task on its own, but will assist another task. Is the best way to describe it. Sorry about that. Little technical difficulty, but to go ahead, we're going to go ahead and once again click the return failure. It'll add a return failure task, and as you can see, it's not currently connected to anything. Within the behavior tree to connect things, you're actually just going to click on this little, I don't know, tab on the bottom of a task, and you'll get a little um, string, and we're just going to drag it into the wait, and then we'll drag the top one into the sequence. So now you can see that sequence now goes to each waits. However, this wait, although it'll always return success after waiting the certain amount, the return failure task will always return failure once the child is done running. So if we go ahead and click play here, you'll see that the first wait runs, but then returns failure. Therefore, the sequence actually stops, and the next 2 waits aren't initiated and are never done. So that is kind of how the individual sequence tasks works. And next we'll go to the selector. The selector is very interesting also, and is another thing that's similar to the sequence. So let's start by going to the scene and opening up the selector scene. We'll save the changes we've made. Once again, the selector scene doesn't really have anything in it, and that's because what we care about is this behavior tree object. Again, let's go to the window with the behavior designer, and you'll see a very similar tree, except the fact that the selector task is here. The selector task is almost the counterpart to sequence, where sequence will do all of its children from left to right unless one returns failure. The selector task is similar to OR and will return success as soon as one of its child tasks returns success, but it'll only do a specific child task. If a child task returns failure, it will then go to the next one. And so if we go ahead and click play here, you'll see that it actually just runs the singular wait and none of the others. To kind of show you exactly how that works, um, we can go ahead and once again add a return failure. Let's try to grab it here. There we go. We'll connect it up to our wait once again by clicking the little tab on the bottom and dragging it to the wait. Cool, cool, cool. And now if we click play, where the sequence would stop immediately because it got a failure, a selector will actually move on to the next wait. Pretty interesting, right? So that's kind of what the selector does. And next we'll go ahead and move on to a specific decorator that I like called the repeater. Okay guys, we're now going to learn about the repeater task. So let's go ahead and open up the repeater scene. We'll go ahead and save the things we did. And once again, we're in an empty scene, and we'll go ahead and click on our behavior tree. So the repeater is pretty self-explanatory. It essentially repeats everything below it. Once again, this is a decorator task, which, as I said before, kind of augments the tree below it or augments the tasks below it. In this case, the repeater will repeat all the tasks that are below it. So if we go ahead and click on this repeater task and go into the inspector, we can actually see what the count is. Currently, the count is 0. And so if we click play, you'll see that it actually doesn't run at all. If we go ahead and change the count to 1, we can go ahead and restart. Whoops, changed it while it was running. My bad. We'll go ahead and run this to 1. And if we open up our console over here, you'll see that our behavior tree, because of the sequence, will wait a little bit and then log something to our output. Just a quick side note, the log simply, as you can see, logs something to the console, and you can put the text that you want it to log to. Now, if we go back to the repeater and increase this number to 2, once again, I did it while the scene was running, my bad. But if we change it to 2, we can go ahead and click play again, and you'll see that the sequence will go. It'll wait, it'll log, it'll wait, and it'll log again. So the repeater is a really useful tool. There's another thing we can do called repeat forever, which, again, I keep changing that in the scene. But we can go ahead and click repeat forever. And if we go ahead and click play now, it'll keep waiting and keep logging over and over and over again. This is particularly useful because sometimes in your behavior tree, you'll end up with it bottoming out and simply stopping. And so the repeater with repeat forever is super useful if you want an AI behavior to continue forever. Another really useful way is one of these options here that I said I'd get to throughout the tutorial. One of these is restart when complete, and that means when it gets to the bottom, it'll actually restart. I can show you that right now. If I uncheck repeat forever and still have a count as 2, but I restart when complete, if I click play now, um, you'll go ahead and see it does the output twice, but then keeps going because essentially every time that the behavior tree completes, it's restarting. And just like that, that's the basics of the repeater task. And just to kind of explain, I'm going to go over a lot of simple things in this tutorial, and then we'll go over some slightly more complicated things. But the big point in this is that with a lot of these basic building blocks, you can actually build pretty complex behaviors, and we'll go over that with the selector and the sequence again once I'm done explaining some of the other basics. Okay, guys, we're now going to be going over the parallel task. As you can see, I've already opened the scene parallel, but you guys should do so. And as you can see, we actually have an agent now. So essentially what the parallel task does is the parallel task runs its children well in parallel. First, let's go ahead and see what will happen. Sorry, didn't mean to click that. So we go ahead and click play. It'll seek, and this sequence task will also run wait, and you'll see a log to the console, and everything's all good. Again, we'll run that again. As you can see, if I pause it right here, you can see that 2 tasks are actually running at the same time. The wait task is running, and the seek task is running. If we unpause it here, we'll see that that returns, and then the sequence also returns. Let's go ahead and go over to the wait and make it maybe 1 second. And if we go ahead and click play, you'll see that even though the sequence one probably should finish first, seek will actually continue to run. And however, the parallel task works very similar to the sequence task in that for it to return success, all of its children need to return success. We'll go ahead and select the agent, and let's go ahead and there we go, it's showing up. Don't know why that happens sometimes. But yeah, let's go ahead and connect these. And you can see that if now I click play, when this sequence returns failure because, well, it failed, the parallel task itself will also return failure. And then this seek will stop running. So, but there's actually, if you go ahead up here and search parallel, there's a few different forms of this parallel. So if we get rid of this here, so if we go ahead and delete the normal parallel, let's go ahead and do a parallel selector. And like I said that the last one was similar to sequence, parallel selector is actually very similar to, well, a selector as we went over earlier. So now if I go ahead and click play, even though the right child returns failure immediately, seek will still continue running, and the parallel selector itself will actually return positive. And so, like the selector, it'll do both tasks and just wait for one to return failure, similar to an OR operation, versus this normal parallel, which um, works as a sequence and will functions similarly to an AND operator. And last but not least, we're going to look at the parallel selector, or not the parallel selector, sorry, the parallel complete. So let's go ahead and put not another parallel selector. We don't need that, but a parallel complete. Gonna reload the scene real quick. Perfect. Yeah, if you there's a few bugs that I personally haven't learned how to fix other than simply reloading the scene. So for some reason when you click on any of these tasks and they don't add in, or when you right click you don't get this large thing, simply reload the scene. Not really sure why that is, but we go ahead and delete this parallel selector task and now do parallel complete. Parallel complete's kind of like in the middle of the two. It will wait till its first child returns, and it'll return whatever that first child is. So here, if we click play, you'll be able to see that because return failure returns first, everything fails. However, if I were to go down to this wait statement and go to the inspector and maybe make it wait 4 seconds, which is longer than the seek task itself takes to complete, and once again, I did it while I was playing, my bad. Make that do 4. Once again, this is now 4. We go ahead and click play now. The parallel complete will run all these at the same time. Seek will finish before the wait actually finishes, and the parallel complete will return positive because it's the first child to finish was a success, and it will immediately cancel all the other children. And so there's a lot of cool things you can do with that. I mean, you can have Parallel be running 2, 3, 4 different tasks at once, which really extends what you can do with your AI. And once again, this is all super nice because you don't have to do anything with coding as of now. You can put all of these tasks just in and things will work on their own, and it's a lot more visually pleasing. And so now that we've gone over the parallel task, I want to go in and revisit the selector task over here. So if we double click on that, we'll see a the behavior tree we're looking at. But I just wanted to show you that there's some creative ways that you can actually use the selector and the sequence task and everything together actually. So if we go ahead and move our selector task, and then we go ahead and let's try to grab a sequence task. Perfect. And we add that into our scene. And we put that in between our selector here. And then let me zoom out a little bit, and then we copy and paste, and we get a new wait task. We can actually see that the selector task will run because the sequence task tells it to. It'll return positive because the middle wait task wants to run, and then the sequence task will then run the next wait task, and this itself will actually return positive. And if we continue down this and we go and pull in a return failure, which for some reason is not pasting, and we go back to the behavior tree, and then yeah, that's it. My bad. Good to know that I figured that out now. And if we go ahead and we return failure rather than this, you'll see that as the sequence task is supposed to, if one of its children returns failure, it itself will return failure. And so that'll happen. And actually, we can watch this and we can get another selector task. In this case, grab this. Oh, oh, stop the scene, of course. Grab another selector task, connect that to there, connect that to there. And this selector task will then um, see that the sequence returns negative, and then we'll then run this wait task over here. So I know it's a little complex and it's a little hard to see, but if we zoom out, you'll see that step by step, this entire tree is run based on the fact that the selector runs the leftmost child, which is a sequence, which then runs its leftmost child, which is a selector, and that starts by running the wait, which it then gets as a failure, so it runs the second wait, which returns positive, so it doesn't run the third one. It'll then run, the sequence will then say, I got a success from this selector. I'll run my rightmost child, which returns failure, so it's negative. And then this selector will see, oh, I didn't get a success from my first child. Let's run the next one. So as you can see, you can really branch these into pretty complex trees, and this is just using 2 of the composite tasks, which composite tasks, if I haven't explained earlier, essentially are selectors and branches for your tree. We've gone over all the parallels, we've gone through the normal selector, we've gone through the sequence, and there's different variations such as the random selector, which I'm sure you can imagine randomly selects from its children. There's a priority selector, which selects based off of priority. There's random sequence. And everything that has the same name, such as all the selectors, all behave the same, and all the sequences also behave the same. As I said earlier, sequence is kind of like an or, it'll run till it's given a success. Or sorry, sequence is more like an and, it'll run until it gets a failure, where selector is more like an or, it'll run until it gets a success. And so I just really wanted to demonstrate that you can really expand this pretty quickly into something complex, even though I'm just using wait tasks. The next thing I want to do is I actually want to return back to the initial demonstration. And that's here. If you don't remember, if I go ahead and click play, you'll see that this enemy is going to move across the screen, and this capsule, once it's within its sight, will then go ahead and decide it wants to follow it. Um, and actually, this seek task, if we stop and look in our behavior designer, this seek task isn't something that's built in, and neither is this can see object. These tasks aren't normal. They're not in a composite. They're not a decorator. They're not an action um, or reflection. It's actually specifically designed. And so if we go ahead and click the task, you'll see there's going to be two C# scripts. And you can notice that these are both under the namespace of behaviordesigner.runtime.task.tutorials. Um, and it's pretty interesting how to write these, but first I just want to dive right in and kind of show you what's happening. So if we go ahead and open the seek task, which should open your Visual Studio, and we scroll up to the top, you're going to see a few things. You're going to see um, a few public variables with this weird tooltip. And actually, if I go back to Unity and I go onto the inspector here, click on the agent and click on the seek task, you'll see that there's actually a few the same public variables. When I mouse over them, the tooltip's there. So for speed, you can see the speed of the agent, and that's exactly what's defined here. And it's a public shared float, and it's the same for actually all of that. Um, and so the way you kind of define these is you're going to put it in the namespace behavior designer dot whatever. I'll go over that in a second. And you're going to put it into a task category, and then it's also going to have a task icon. Now, this task icon is seekicon.png. It's actually in task editor, skin color seek icon, which if I go into here, you can see that there's PNGs for it, but specifically writing it, you don't really have to worry about that. We can actually go through, and it actually looks pretty similar to a normal Unity script. Um, so the only difference is in a slightly different namespace, and it has a public class seek, which inherits from action. So it has a public override void on awake, which grabs actually a nav mesh agent. If you were here for my last tutorial, this specific seek task uses nav meshes because that's the easiest way to get something to move towards another object constantly. You don't have to do it this way, but this is how it was written. And then it has an on start, which does some weird things. You don't really need to worry about that right now. This essentially checks Unity versions. You don't have to worry about that. But as you can see, on start, it sets destination and to the target. And if we go down to um, the target function, we can see that if the target value is null, then is not null, then that's what we say is our target. Otherwise, we follow a target position. And so if we actually go back, we can see that if we click on the agent and once again click on the seek task, then you can see that the target is the enemy. But if we go to the enemy and click on our seek, that the target is none, but we has a target position, which is why the enemy, even though it's seeking, is simply going from point A to point B, while the agent itself is going to follow the enemy that's going across. Okay, so next I'm going to show you, as I just show you exact kind of how to write your own task if you would like to implement it similar to seek and this seek and can see object. So I'm just going to go back into my base assets folder. I'm not in the tutorial or anything. I still have this scene open. We're going to keep this open. I'm just going to right click and click create C# script. And I'm just going to go ahead and name this test task just to kind of show you how this works. It's not going to have any sort of um, legitimate use, but it'll be useful to show you exactly how to get a C# script as a task within the behavior designer. So as you can see, I've created it, and I'm going to go double click. It's going to go ahead and open, and most of you guys should be pretty familiar with this. You see your public class for test task, and it inherits from mono behavior and has a void start and void update. Now, first things first, we're going to go ahead and we're going to say using behavior designer dot, whoops, dot runtime dot tasks. Okay, so make sure you're using that. And now I'm going to do probably the most anti-unity thing that I'll have taught anyone, and it's you're actually going to get rid of this mono behavior. We don't want our test task to inherit from mono behavior, and instead I want it to inherit from an action. Um, and just like that, your task is actually ready to go. Unity will completely be fine. So if we just go ahead and save test task and reopen Unity, it'll go ahead and compile your C# scripts. And once it finishes that, if I go ahead and once again click on agent and go to our behavior designer tree, and I go down to my actions, which I have minimized, yours shouldn't be, you'll actually see test task right there. And I can click it and it'll be loaded directly in. Now, it's not quite done because it's an action. So it doesn't do anything, but that's fine. I could theoretically hook this up and boom, it's hooked up to the behavior tree. You actually have to do nothing else. It'll go ahead and immediately run that C# script that I wrote, which currently doesn't do anything. I'm not exactly sure how it's going to behave, but if I click play anyway, the sequence won't even work because it'll cancel the object and then it'll seek. And once it actually gets to and finishes seeking, my test task will run and return success because it doesn't do anything. Um, but I know it's pretty cool, right? And that's all you have to do. And you can actually change what type of task your task is. Now, I made it an action. Actions are all these things you see here. Pretty self-explanatory. They do something. You saw the log, you've seen the idle, you've seen the wait. They don't continue to branch. As you can see, they don't have a bottom tab and they never connect to anything. Actions are done, and then they will return a success or a failure. However, you saw decorators, which essentially kind of modify the branch below them, and you saw composites, which help branch like selectors. And if you go down here through all of these, I know there's a lot of them. I probably should have just minimized it, that's why I had it minimized earlier. But if we keep going down, I'm just going to minimize this for sake of time. If we minimize actions, we can see conditionals, which is similar to this can see object. Conditionals don't actually do an action, but rather simply return success or failure based on if something has occurred. So you can see that there's a lot of base ones, such as has entered collision or has entered 2D, which is super useful because I'm sure a lot of you guys have typed in Unity, on trigger or on collision trigger, which is really useful because now you can actually just bake that directly into your AI behavior. There's some reflection, and this tutorial one, which I haven't opened, but I can open now, is this can see object. And as you can see, this class inherits from conditional. And you really don't need, by the way, all of these task categories or task icons or tooltips. I know it makes it look better, but really, as you saw there, like my task didn't have any of those, it just kind of gave it a default. But as you can see, this inherits from conditional and has a task status on update. And it says the returned object dot value is within sight. If that's null, it'll return success. Otherwise, it'll return failure, because that means if you return success if anything is within sight. And if we look at the within sight code, it's basic Unity code. It's nothing really different than anything you haven't seen before. Rather than go ahead and explain all this since it's kind of not behavior designer. It's just pretty basic Unity code. I would highly recommend you looking into this yourself, kind of exploring it, see how this is written. But for now, I can just go ahead and show you that if I were to, sorry, go back into this and go back into my test task and rather make it inherit from conditional, if I go ahead and save, go back to Unity, reload the scripts, you'll actually see in the conditionals our test task once again. And because it's a conditional, it has a different default icon, but it still only has one. And you can do this for a lot of things. I mean, I can make it a composite. If I go ahead and make it inherit from composite and go back into Unity, you can go ahead and see that our test task is now here, and now it actually gives me an error because a composite's supposed to not be the end of a tree. It's supposed to connect to something. And so this, and as you can see, there's nothing in my inspector, but uh, it's actually giving me an error. And if we click on this, you say the test task is a parent task which does not have any children. Um, so that's kind of how you would start writing any sort of thing, any sort of task for your behavior tree. Once again, I'm really glossing over a lot of the basics here, just to kind of get you familiar with everything, because once you hop in, it can get kind of complicated, and you really have to know the basics, especially since written tasks all of a sudden add a whole new level of like what you can do with your AI. And I know I said a lot of this isn't coding, um, which is true. A lot of, you can probably find a lot of tasks on the internet, tasks that people have written, things that you can do, but the only part of this that really requires coding is if you want to design your own tasks. The behavior tree itself, as you've seen through this demonstration, is almost completely flawless and code free. And so just like that, you can design all of your different tasks. So I'm going to go ahead and delete that task, go back to assets and delete this test task because, well, that was just kind of to show you exactly how you would start um, designing it. And like I said, I would really recommend looking at the tasks that they've already written because that gives you a lot of insight about, exactly what they do since they're pretty simple in the grand scheme of things and kind of create a basic AI. If you're confused with any of the nav mesh things they're doing, I'd highly recommend looking at my last tutorial also. Okay, so now that I've gone through a lot of the basics, like most of our tutorials, I really like doing a sample project to kind of show you the tool in action and kind of show you how it can be used. Now, the one thing about this behavior designer is that you get a pretty complex game if you want to see a complex behavior tree, which can kind of make sense if you think about it because it needs to have a lot of different variables. And I don't really have the time to go from the ground up and teach you, code a bunch of tasks, um, basically code an almost entirely basic game just to show you how behavior trees work, especially since this tutorial shouldn't be any longer than an hour and a half, 2 hours. But I do have a few sample projects that'll really demonstrate how much easier the behavior designer makes creating AI. And so first off, what I want to do is I'm going to import another package. So we're going to go to Assets, Import Package, Custom Package. This is going to be a new one um, that I will go ahead and download. It's actually going to be a real-time strategy. Okay, guys. Next, I would love to show you a real-life example of an actual game. It's going to be another Unity package you're going to have to download. Again, I apologize for all this downloading, but like I said earlier, with the more complicated uses of the behavior tree, it's going to take way too much time to build up from scratch. And so I'd much rather just kind of show you these already built examples. So once again, we're going to go to Assets, Import Package, Custom Package. I already have it downloaded here. Again, the link will be provided for you guys. You can download it. So let's go ahead and double click that. It's pretty big. We're going to go ahead and go click Import. And we're going to have to wait a little bit. It happens. It's okay. And slowly but surely, this will finish. This specific package is an RTS game. It's going to be pretty simple. You're going to have sets of harvesters that are going to mine from a gold field, which will then allow you to buy units at the barracks and then proceed to attack the enemy's turrets and so on. So you should get a folder that says, that is this folder. It's the um, behavior designer samples, and we're going to go into this RTS, go into the scene and open that up. And if we go into the head and go look at this, as you can see, it's exactly what I said. I know it's a little, subpar. It's not great, but that's okay. So these three cars are the harvesters, and these are our two gold fields. You can actually see that here. So each of these gold fields allows to be mined. We have the NPCs, which are our three harvesters, which, as you can see, have behavior trees, which we'll be looking to in the moment. Um, there's the enemy base all the way over there, which then encompasses a power plant and a turret, which also has an AI that we'll look into. And you have our own base, which both has the barracks and the refinery where the gold's left off. So if we go ahead and click play, you're going to go ahead and see that these two cars go. They mine for a little bit, and they go back and return to the refinery, and the next harvester will go to the next available gold field, and this will rotate. They'll be able to go into the refinery one at a time, and all of this is actually designed with behavior trees. If I go ahead and click on a harvester and open the behavior designer, you'll see that this slightly more complicated behavior tree is actually something that's constantly going off. And we can see that there's also the behavior tree over here, which uses that restart when completed option that I was telling you about, along with some variables and behavior description. And so with that, let's go ahead and stop running and let's hop right into this. So we start, of course, with the entry. Oh, we start with the entry and we start with the sequence, which if you recall, will just execute things left to right as long as they don't fail. And we have this next gold field target. So let's go ahead. We can actually click these three buttons and click edit script. And this is the script. So once again, these task categories, task descriptions, and tooltips are all things that make descriptions easier. They're attributes you can add. I won't be going over those today since they're pretty much just fluff for everything. They're not necessary at all for function. But feel free once again to look up those on your own. I mean, it really helps, I guess, if you're like working on a game with other people and you like are defining something that you're not sure what it's going to do. But I can see you can say on start gold field manager is equal to gold field manager dot instance. So the gold field manager is where is it? There we go. Is a defined public class. And what this does is it takes a list of all the gold fields. So if we exit out of that and go back to Unity, we can see that there is a gold field manager here and it has a transform of all the different gold fields which are here. So that's basically all it is. So if we go back to Visual Studio, that's just what happens on start. And essentially this task status on update means that the target dot value is going to be equal to gold field manager dot next gold field transform. So it's essentially just going to get the next gold field, and then that will return success. And if we go ahead and look up here, we have a public shared transform target. Now, this is pretty important. So shared transform is a shared variable, and that functions within the behavior designer. So if I go back to Unity and I'm on the behavior designer, and I go to the harvester, if we go over to variables, you're going to see some global variables here. And it's actually quite interesting. These can be shared among scripts. So if I go ahead and go into the inspector of the next goldfield target, you can see that I've assigned the target variable, which if I go back to here is you see here a public shared transform target. I've assigned it to be this target global variable. And if I go over to limited resource guard over here, you'll see that this limited resource transform, which I'll show you in a moment, is also assigned to target, which means both of these variables within these two separate scripts are actually pointing to the same global variable, which can be super handy. And so what's happening here is the target's value is being set to whatever the next gold field transform is. And that's on update. That's every time the task is run. And then it will return a success after it's done that. And so, as we know, sequence moves left to right until it encounters a failure. And so next we'll go to the limited resource guard. So if we look at this, the limited resource guard's a little longer, but it's not too complicated. So on awake, it just makes sure it exists. And on start, it says limited resource is equal to limited resource transform.value.get component limited resource. It's essentially finding the object from the target. So if we go over here to gold, you can see it has a limited resource script, which if we open that, I know I'm going through a lot of scripts, we'll go over them again. But if we go over to that, it essentially just says if it's occupied. Again, I'm not going to go line by line through these, but I'm going to give you the basic overview. Feel free when you download this to really look through it and kind of get how everything goes through. I'm sorry that I can't go super in depth, but I'm really trying to save some time. But as you can see, this is essentially has a public transform that's occupied by, it has some get and set functions, and then essentially the trigger is what causes occupied by to be set. Um, so if we now go all the way back to the limited resource guard, which is our decorator, what'll happen is it says it'll try to get that limited resource from the target, and then it essentially is when it's executing, it gets the limited resources occupied whatever transform that's on it. So what you can imagine is the harvester runs and finds the next gold field. Okay. And then it'll see if something's executing there with the limited resource guard. Because remember, it's this target, this limited resource transform is shared. So a harvester will get a target, and then it'll take the limited resource transform and essentially check if it's occupied. You see here we return if if occupied by is null and it's not executing. So if no one's doing that, then um, we make sure that that's all right, and then we see if that's a success. Now, to continue down, we then have another sequence, which starts with seek. So it finds the gold field, then, right, because sequences move left to right, sorry, we repeat gold collection a few times. So we harvest the gold, then we wait. Then we harvest the gold, then we wait. And currently its repeater is set to 5 times. Again, you can change this all and it'll directly affect the AI. Then remember we have a selector. Now selector does the first thing that's available. So the first thing that is that returns positive. Remember it's like an or rather than and. So we check is resource available, which is a conditional task that determines if the limited resource is occupied. If it's not occupied, we go to the wait time, and then we go to the unloading dock. So this is resource available here is a little different than limited resource guard. So once again, I'm going to quickly go into the script. This is just saying if the resource is occupied, return success, return failure. Pretty simple. This will make a lot more sense when we run it and you can kind of see what's looking up. And then finally, we go to limited resource guard again. And this limited resource guard here is actually, you can see the limited resource transform here is not set to the global target, but rather it's set to the refinery. And so that way the refinery is also a limited resource that can only be occupied by a singular harvester. And then that sequence goes to the unloading dock, waits to unload the gold, and then actually runs the unload gold script. So I know that's a little complicated, but I'm going to go ahead and show you it in action, and we can kind of see exactly how all of this works. So let's go ahead and click play. And we're seeing this first harvester. So it's found a limited thing, and right now it's harvesting the gold. And now see, they kind of argued a bit over whether or not this was available. And it got resource available, unloaded, and now it's going again. Now I know it's a little fast, but I'm going to let it run for a little bit. As you can see here, if we select this one, if we go to the scene, this is the one we're currently looking at. So it should be harvesting gold, going back and going to the wait zone for the refinery, which is, you can see it went down, go to the wait point, and then go to the unloading, or go into the wait point and then ran the limited resource guard. So I'll let this run a little bit. As you can see, it makes it a lot easier with the visual debugging of the behavior designer. And this is definitely slightly more complicated, but you can see that these are all interacting with each other. Um, and that shared variable is being shared within the harvester itself, not between harvesters. You can see if I click on this, it's something else is completely happening, and it's running through. And we basically have fully functioning harvesting AI that the only code you really had to write was the actual movement, and the AI is doing itself. You didn't have to write all of this, check if it's available between different ones and all of that. So it's definitely like super useful, and like this complex example would take a while to build if you had to code everything, but it would be a lot faster to do once you get to this. Okay, so we just saw how these harvesters work in action. I just like to really highlight an aspect of the visual debugging of Behavior Designer that I don't think I've specifically mentioned is when I click play, obviously the things highlight as they're functioning, right? But if I also pause the game, though that highlighting stays on dependent on the current state. So if we look at this harvester, which if we go to the scene, you can see is the one currently harvesting gold, or it might be done. And we go to the behavior designer, we can see that it is actually currently harvesting gold. It's in the repeat function. It's currently waiting. It's going to harvest more gold. And it should be pretty similar for this other harvester here, which if we look, you can also see that it's on the same exact step. But this last harvester here, is still stuck at the limited resource guard because there's actually no open gold mines. So it's actually stuck here because this hasn't returned success or failure yet. And if we go ahead and click and we resume, you can see that as these go here, and let's pause one more time, this one has now started seeking to the gold field, and these other two are now in different states. This first harvester, which is currently at the refinery, or I guess unloading dock or whatever you'd like to call it, is now in the wait portion and it will unload the gold after. This other harvester, however, has gone into the selector and the resource, it's seen that the resource available is actually um, not available. So now it's seeking to the wait point, which I believe if we go to our refinery, we can see that the waypoint in the scene is actually a transform right here. You can see the little circle there. That's the building, and this is actually the waypoint. So super cool with Behavior Designer being able to actually see this in action while it's playing, and it makes it a lot easier to debug too. I mean, debugging behavior trees code-wise can be really hard, and luckily this kind of just shows you where things are entered. So if it's entering or doing a wrong pattern, you can kind of see it from there. Now there is one other behavior tree, which is pretty simple and not too complicated, but something I'd like to highlight, and that's the turret. So the turret in this scene, sorry, is, right over here. I'm actually going to drag this down to here to make it a little better so we can see both at the same time. So as you can see, this turret down here has an entry in the sequence, and step one is within distance. Um, so it starts firing at any unit that comes within distance. It gives you a magnitude, whether or not you can turn on if it's within line of sight. It has a target variable and target tag. You'll see these in a second, um, and I'll go into it a little deeper. But then we have a decorator that's actually until failure. So this is similar to the until failure is pretty similar to the repeat, except it just keeps going until the sequence returns fail. And so it'll actually keep trying to see if the current unit is alive, which as you can see is once again using a global variable, which is its target, which gets set for the during within distance. And if it is alive, it'll fire a projectile, and then it'll wait, and then it'll check if it's alive again, fire. And if any of these fail, then this fails. And as you can see, once again, if you go into the turret and the inspector and you scroll down to the behavior tree, you can see once again it restarts. Um, it restarts upon completion. So once it completes this or fails or whatever, it goes back. So I can kind of show you this in action once again. Um, as you can see, nothing is within distance, so it keeps failing. And remember, when sequence, when one thing fails, the whole thing fails. It doesn't keep going to the next one like a selector. And so this just keeps failing and restarting, and I can show you in a second how this game actually works. Okay, so now we're gonna actually I can actually show you how some of these behavior trees work in action. But first, let me go ahead and go into the scene. And as our people are collecting gold, if we go to the game, which we can go ahead, we can switch cameras, we can look around. We actually create units. Now you can see they're kind of hard, so I'm gonna pause right here, and you can kind of see how I've created a few units here, and these actually have their own behavior trees. So we go ahead and click on here. You can see entry and sequence, and this will return success once the sequence finishes. And it's similar to return failure. And so you can see here that the first step is it sets the target to the turret. You can see that it actually, in the script itself, it specifically does the target name, and the target variable, once again, is one of these global variables. Uh, and so if you really would like to, you can go ahead and click Edit Script, and you can see if the target name.length is greater than 0, target it tries to find whatever the target name is and the transform. And then on the update, it sets target variable dot value equal to target. So once again, it's using a global variable and has a shared transform for target variable. And so once again, you can go into this code yourself, but it's pretty simple. And so you can kind of see how this target variable, which is then set to target, and then it checks if the turret's alive. And then this is a behavior tree reference. Now, this is something that I really wanted to get to, and it's also super cool. And you can define a set of behavior and actually save it and then reference it in other behavior trees. So if you go over and you click resources under this RTS, you can see there is this attack behavior tree. And if you click on it, and once again, it's going to tell you, welcome to Behavior Designer, but you can see that it's a completely separate behavior tree. And you might want to ask, why exactly would you want to do this? And that's because if we go back to the clone, once the base is destroyed, we want the same behavior. We still want it to attack then the power point. Once again, as a reminder, this is the turret here, and this is the base or the power plant. And so rather than have to write the entire behavior tree twice or get it make it, make this behavior tree really big, you can actually define it separately and simply attach it like this. So if we go over into our attack, we can see that it gets into the next attack position, um, and then go ahead and plays a specified animation, seeks towards the target, plays another animation, and then we use a few other different tasks here. The inverter is pretty simple. It does exactly what you think it was. It inverts signals, so if a failure returns, it will return a success, versus if a success returns, then it'll return a failure. And once again, we have this until failure block, and we have a sequence that's similar to the turret. We check if the target's alive, we fire a projectile, and then we wait. So super cool. Just again, more different ways you can kind of go about creating your AI or creating this. And so let's hop back in and re-click play, or unpause it, I guess. And let's see these guys in action. So we've created our units, and we actually click attack, and then it runs that, and we can see it's attacking the turret, and the enemy health is going down, and that turret is also firing against us. So we managed to kill one. I know the cameras are a little weird and janky, but as you can see, we've destroyed the turret, and we're now attacking the power plant with our one remaining guy, just enough, and we've destroyed the base and beaten the game. Pretty cool. And that kind of like shows you how you can actually implement this AI into a real game. You can code any sort of task you want and then just attach it all. Like I said, the coding part of the actual task, although it is slightly intensive, really is all up to you on how complicated you want to make it. And everything after that is super easy. Attaching these tasks together, debugging, and you saw it from this RTS. Although I know I went through it a little fast, I really encourage you to go back through the video and see where I explained it. If I didn't explain something too well, I definitely think you go into the code, go into the behavior trees, like really watch as they go through. It's definitely, this entire behavior designer is really example based, and it really helps to explore with your own hands. And from now until the end of the tutorial, if any questions come up that you can't answer yourself, please feel free to reach out to me on Discord, message me. So, and I will do my best also to answer any questions. But we do have one other example that I love to show. It's a capture the flag example, and we'll be going to that right now. Okay, so before we end the tutorial, I'd like to show you one other example just to kind of give you a little bit more breadth on behavior trees so you kind of know a bit more what's going on. So this is going to be the capture the flag. So once again, we can go ahead and open that and open the scene. We'll go ahead and say what we've done here. And this is, whoops, I'm going to drag the game back up into, or not the game, sorry, the scene back up into here, just for ease. And so this is capture the flag. You can see in the middle that there is a flag that one must capture, and there are three red defensive NPCs and three patrol NPCs, and then two offensive NPCs. And essentially, how this game works is the blue NPCs are faster than the red ones, and they're going to try to get the flag and return it to the capture point, which is right there. Now, with that in mind, let's go ahead and hop into the into the behavior trees. Let's start with the defense. As you can see, um, the defense has a little circle around it, and if we go over to behavior designer, once again, this is the defend one, the flag not taken behavior. There's actually two behaviors here that we can see, but we're going to start with the not taken behavior. So the defense not taken behavior starts with a selector. This selector then starts with a sequence, which if an enemy is within sight, we will go ahead and set a target to an enemy. Once again, these are these global variables I talked about earlier. Because so when the within sight script goes ahead and sets that target variable, which if we go ahead and go to the inspector and open that script, we can see that the target.value is set to one of the two targets if a singular target is in sight. So again, NPC view utilities dot within sight. We set the target so that other tasks will know which transforms within sight, and then we return success. Otherwise, we return failure. And so then we go back. Oh, there we go. Sorry about that. I'm not really sure what happened there. But yeah, if we go back and we can see that if the target's not within sight, this sequencing will entirely return false, and then the selector will move on to the seek, which will go back to the starting position. And once again, as I've said, you can kind of go down and look at this behavior tree object that's on there, and it restarts when completed. And so on the and like I said before, this within sight sets this target global variable, which is then used by the defend, and that is always set to whatever the enemy is, along with this move and rotation speed are also actually global variables, so I can change the move speed for everything at once rather than one at a time. Okay, next, the next behavior tree for when the flag is not taken that I would like to look at is this offense. Yeah, so like I said, we just went over the defend when the flag's not taken, and now I want to go to the offense when the flag isn't taken. Um, and yes, so once again, this flag not taken, you have a selector. So we go ahead and look at this sequence, and we start with within distance. This returns success if there is an enemy within the distance of the offense. So as you can see, there is a 6 targets, the three defend and the 3 patrol units. And if any of those are within distance, this will return a success. In which case we actually want to invert it so it returns failure, and the selector then, because the sequence returns failure, the selector will then go to this, and it will actually flee in the opposite direction of whatever this enemy is. Because once again, we have a global variable called enemy that within distance will set, and then flee will run away from. However, if there's nothing within distance, which means this normally would return a failure, this inverter will return success. Therefore, the sequence will cause the next task to go, and the offense will actually go towards the flag. So you can kind of imagine how this offense is essentially going to walk towards the flag unless it sees an enemy, in which case it will run directly away from it. And the final behavior tree we want to look at when the flag is not taken is patrol. And this one's really simple, which is why I put it last. Essentially, there's a sequence. It will patrol. It'll move from waypoint to waypoint. Um, again, this can be done with actually nav meshes, which I believe is how they do it here. If I remember correctly, yep, it is a nav mesh agent. Again, look back at my old tutorial that'll kind of explain how nav meshes work, but instead it'll patrol from waypoint to waypoint, and patrol will return false when an enemy comes within sight. So this code's, again, a little complicated. I definitely recommend looking at it on your own, but essentially this is just some nav mesh stuff. And then on update, it'll go through, see if any of its targets are within sight, and if there's no path, it'll then it'll go to the next waypoint. Um, so again, look through this on your own. I don't want to spend this entire time boring you with going line by line through this. But this is like I said, this is as you can see, an action task with some tooltips, and it does all of these things. On update returns a task status, so that's how it keeps track of whether or not it's a success or not. And then, like I said, why whenever I click Alt Tab. But yes, so there's, as you can see, if it'll patrol, and then once that'll return failure when an enemy comes within the sight. Otherwise, and if that returns failure, this entire thing will return failure, and otherwise it'll seek. So those are kind of the base behavior trees, and so next we can kind of go on to how they actually function within the. Okay, so I just like to correct something I said earlier, or just now. This patrol actually returns success. I was speaking wrong. It returns success if it finds an enemy, and then it will run the seek program. That because that's how sequences work. Funny how that works. But in this case, let's go ahead and now we're going to take this scene. I'm actually going to drag it down here so it's a little easier to see exactly what's going on. We're going to actually start running the game. And as you can see, our blue offensive players, if I go back to the scene, are going to run towards the flag and actually make it. And as soon as they grab the flag, everything goes. And when the red touches, then stuff respawns. However, as you can see, they're slowly making progress until that one blue thing returns the flag all the way and twirls around. So pretty cool. And I'm actually going to show you another really cool way to debug, and so we can kind of observe what's going on here. So let's go ahead and stop the game and go over to our offense tab. On this flee task, I'm actually going to right click and click set breakpoint. And that'll actually pause the game whenever offense one runs into an area where it has to flee or that proc. So let's go ahead and start again. You can watch the behavior tree. Oh, scene. Let's select this. And it's going. And, oop, my bad. Specified cast is not valid. Oh, that's my bad. The breakpoint did not quite work there. Let me go ahead and says not defend. I don't know why this happens sometimes. It's very temperamental, and I haven't figured out why it is. So once again, just reload without changing anything. Let everything start up, and then we'll select offense one. And you can see that it doesn't actually flee until right about here. And you can see it flees for a little bit until it gets out of range. So now let's right click, let's set that breakpoint. Let's click off so apparently I don't accidentally delete a behavior tree. Again, weird that that's happening. I haven't run into this issue before. Start playing. Perfect. And, it seems like that breakpoint is making it not happy. And I'm very confused as to why. Okay, sorry about that. I cannot seem to get this breakpoint to work. It keeps the same thing. I keep setting this breakpoint, and as soon as I click play, the behavior tree seems to just not work. I don't really understand what's going on, and I couldn't seem to have figured out a problem. So I'm not really sure why breakpoints aren't working. I will post something if I can figure that out, post making this video. But again, it's been really weird, and I've had to reload the scene a bunch of times. I even had to re-import the package because I messed something up. not quite working. But something I would like to show is now that the game is working and I haven't fucked it up, uh, we can go ahead and click play. And as you can see, if I go ahead and go to the NPCs, go to the offense, we can see that it's running. However, now there's nothing. There was nothing running for a while, and that was because as soon as they grabbed the tree, it actually entered a completely different behavior tree, and that is the flag taken behavior. Now, if we go over to the actual object itself, specifically this offensive character, we can see there's actually two behavior tree objects on it. This first behavior tree and the second one. This is flag taken behavior, and this one's flag not taken. And you can see if I close this navmesh agent to try to get them on the screen at the same time, yep, we can actually see that this behavior tree, the flag not taken, is the one that starts enabled, and that this other behavior tree is actually disabled. And you can see that also they have two different group numbers, 0 and 1. And what that is that's actually, if I believe this is the CTF game manager. Within this, the game manager can change the group that these things that they're in, and as you can see, they were in different groups. So if I go ahead and see, you can see active group. So if I active group, um, this active group is which behavior tree we should be in. So that is essentially how you can kind of switch between these two different lists of behaviors, which is a list of all the flag not taken and flag taken behaviors so they can be enabled or disabled. So that's how they're doing the two. And so then we'll now hop back in and go over the flag taken behavior since I just went over the all flag not taken. And once again, it's pretty similar. It's nothing too complicated, nothing you haven't seen. It's a selector, and then we have a sequence. And if the current unit has the flag, if yes, then seek the capture point and celebrate once we get there. However, if for some reason it dies or has to respawn, this sequence will fail, and the selector will then go to the next sequence, which will see if the other unit has captured the flag. So this is maybe because it itself doesn't have the flag or it dies. It'll check if the other unit has captured the flag, and then it will seek the flag. It'll seek the flag, so it'll follow, and then it will celebrate if it gets to the flag. So once again, we can kind of see this in action. So we are going to click off so we don't mess anything up. Wait for it to start. Click on this, and we can see currently nothing's going on because no one has the flag. But we can actually see if we pause this, what happened was the other unit actually got the flag, which you could have seen in the game. And because it doesn't have the flag, this sequence failed. And the selector selected this sequence, which saw that the other unit hadn't captured the flag yet, which was then inverted, and then it seeked the flag. So let's go ahead and stop, and we can actually go over to now one of the defenders who also have flag taken behavior. And again, pretty simple. If the flag has been captured, then seek the flag. Pretty simple. And then we can go to the patrol, which is also very similar. It will continue to patrol. Oh, sorry, that's flag not taken. We can go to flag taken, which is almost exactly the same as patrol 1. It checks if the flag's been captured and seeks the flag. And so as you can see, this game, which actually has no player intervention, is still a competition between two NPCs. And although currently the game runs pretty similarly every time, as you can see, if we click run, it'll probably get similar. So like this left one will capture the flag first, and then that'll take it to the left here. He'll get captured like there. It'll go back. So you can see this one's continually fleeing from the other one, and it eventually gets over here. It's actually a little different. So there's, some slight variation actually. I'm kind of surprised, but it happens, and eventually, like, see, this one will capture the flag again and go, and they're going, and they're slowly getting there. Oh, well, this man seems to have lost his will, but and as you can see, finally they get it and get back, and he does a fun celebration. But These two examples I really wanted to show you because they're all pretty different games, but they all kind of highlight how you can get pretty complex AI even with not super complex decision trees and behavior trees and with pretty minimal coding. I mean, a lot of these, like this flea, for example, this flea script, like it looks pretty complicated and scary, but honestly, a lot of this is just a little extra to make it look good. You can really go down to the bare bones and kind of get all these things working between the RTS or this capture the flag model. And all these AIs, once the tasks themselves are constructed without coding, as I've said. And so I really would implore you to kind of really explore a lot of the things I haven't gone over. We've gone over most of the composites. I didn't go over any of like the random ones, but I mean like there's random sequence here, which I know there's a long description of it. But if we go to the inspector, you can see like whether it's aborting, what's the seed for the randomization, and stuff like that. There's um, there's of course the priority selector, or that's the random selector, sorry. We can go to the priority selector, which we go to the inspector again, has an abort type, but the priority task, the priority selector task will return success as soon as the child task returns success instead of the running it'll essentially ask which task, as you can see. Uh, and so, like, not even I personally haven't gone through all of these tasks. I mean, like I said, there's all these ones that are just the demos themselves. But if we get rid of, like, those are just all the conditionals, the decorators, the actions. There's so many just within Unity itself, right? There's play a certain animation, set animate physics, like there's it's set up with the animator. So it's really looped in with everything in Unity. And so I'd really definitely like to encourage all sorts of things. Like you can use this not even necessarily to design an AI, but to design like your music player, right? Because you can do all the different audios, and so you can set a bunch of conditions there rather than even like writing that yourself. So I would definitely like in addition to AI, which is obviously its main use, there's a lot of different ways you can explore with this, and I would be talking to you for hours upon hours if I wanted to go through every possible way to use this in Unity. But I really just wanted to kind of open your eyes, show you some of the basics. The most important ones I would say are really these composites, understanding how they interact with each other, is super important. The decorators also really help influence everything. Like you can have this interrupt, which if you put this in, this interrupt task will stop all child tasks from running immediately. And you can then take that interrupt, and I believe there's another task if I remember, which is an action, which is perform interruption. And you can actually go into the inspector, and select this interrupt task. And so now, oh, those will be linked. And so now we know that this perform interruption will trigger this interrupt, right? So there's all sorts of things you can do, uh, that perfect, that can do a bunch of different things. And I know this tutorial has only been about an hour and a half, and I'm sure you'd love to see more, but like I said, it would take way too long to code all the tasks myself and kind of go through like a really complex example. But like I said, really explore this if you got when you guys are making your games. I think it's going to be super useful. Anything that like you can use this in addition to dialogue systems. It makes it really helpful. You can do this with a lot of different things. So definitely would recommend this. Again, if you have any other questions, I'm Kudaloo on Discord. Feel free to message me. I'm personally going to be messing around with this in my free time, seeing that I learned this to give this tutorial. And again, I'm sorry if I didn't go to anything as much as in depth. If you want, like I said, let me know. And I hope you guys had a good Thanksgiving and have a good end of your quarter.